Hello. In this seminar, I want you to evaluate, analyze, and graph exponential functions. I want you to solve problems involving exponential growth and decay. Some vocabulary you're going to come across is algebraic function, transcendental function, exponential function, natural base, and continuous compound interest. First, we're going to start with an exponential function. An exponential function is anything where the variable is the exponent. It's a times b to the x power. A can't be 0 because if it was 0, neither a or b could be 0 because then you won't have an exponent. And b can't be 1 because if we take 1 to anything, we just get the same thing. So an example like 4 to the x, 1/3 to the x, 7 to the negative x. An example, 2x to the negative 3, your exponent is not your variable, so that's why it's not exponential. If I got like 5 to the pi, I don't have a variable. 1 to the x, because 1, b can't be 1, because it's just the same thing. So I want to sketch and analyze the graph of f of x equals 4 to the x. I'm going to describe its domain, its range, its intercepts, its asymptotes, the end behavior, and where the function is increasing or decreasing. Well, since this is the first time we've done this, let's make a table. You can always make a table for a function to get an idea the first time you do it. So I got x, and I'll do 4 to the x power. And let's do some negatives, and let's do some positives. Now I know anything to the 0 power is 1. So I know 4 to the 0 is 1. 4 to the first, well, that's 4. 4 to the second is 16. And 4 to the third is 64. And I know negative exponents is just the reciprocal. So 4 to the negative 1 is going to be 1/4. 4 to the negative 2 is 1/16. And 4 to the negative 3 is 1/64. So I can see my graph is going to be asymptotic to the x-axis and going up. So now the domain, well, my domain could be any number, can't it? So I'm going to go from negative infinity to positive infinity. My range has to be greater than 0. So my range is going to go from 0, can't be 0, so I'll put a parentheses, to infinity. Okay, my intercept, there is no x-intercept because it never crosses the x-axis. It has a y-intercept at 1. So when x is 0, y is 1. And my end behavior. So as x approaches negative infinity, f of x is going to approach 0. As x approaches positive infinity, f of x is going to go towards positive infinity. And then notice when I go to the right of my graph, it's always increasing. So if I pick 2 points on my graph, if one's to the right, the other point's going to be higher. So I'm going to say it's always increasing. And if I want to get a more accurate, rather than just the sketch of what I did, I could actually go into Desmos and graph this. And then there we can see that. There it's 4 to the x power. And that's all you have to do.